Good afternoon, ladies and gentlemen. First of all, thank you very much for this invitation. It's a pleasure to be here, but it was an even bigger pleasure to be able to, an honor to be able to work in the Global Energy Assessment. It has definitely been one of the most fun projects in my life. So after these very interesting discussions, I'm going to jump to present about energy end use, and in particular with a focus on the building sector. First, I will highlight why we should care about energy end use altogether in the sustainable energy transformation, and I will steal or preempt some of the key messages from Naki later on. Then I will tell you an interesting conclusion that we really didn't coordinate at all, and it comes through at least 5 chapters as a key message, that systemic solutions are becoming much more important than individual gadget efficiencies, and I will show it. It was also highlighted by the previous speaker. Then I will show how recent developments in the building sector help this sector in potentially largely contributing to the transformation. Because it is possible now in all regions to build and retrofit very high performance buildings, mostly at costs that pay back. However, after the good news, the bad news is there is a significant lock-in risk, which we have for the first time quantified in the Global Energy Assessment. Also, there are very significant barriers, much more significant than probably in any other sector. So this future, a more sustainable buildings energy future, will only be realized with very strong political will and concerted policy packages. However, the good news is that there are already very good examples out there, although there is also something controversial. I will be very encouraged to bring also controversial points, and I will highlight those related to the net zero energy buildings. So with that, let me now show you 2 slides, which I'm flashing only because Naki will expand on them in more detail. This is from the scenario process of the Global Energy Assessment, which was the key integrating element in this work. And I'm not going to go into detail on this, but basically the important message is that if you have these 3 scenario groups, the supply, mix, and efficiency scenario group, if you push the efficiency lever hard, so if we look at the efficiency-dominated scenarios, those give you the highest level of flexibility on the supply side. So you will be able to afford much more choices on how you want your energy supply to look like. So that's one of the advantages. Another advantage is certainly the costs of such scenarios are typically lower than the other scenario families. So this is how energy future roughly will look like in the Global Energy Assessment, divided by the key sectors, how we slice them up in the Global Energy Assessment. This is in the supply scenarios, and this one is in the efficiency scenarios. But in all these scenario groups, you see that it is possible to contain residential and commercial the most. In fact, it's even possible to reduce total residential commercial energy use, so building energy use, as compared to the other 2 sectors. Although here transport is also getting reduced, but industry is more difficult to contain. So what I mentioned was that there was a very interesting, at least to me it was quite interesting, that I had the mandate to look at consistency among the different chapters, so I was reading through these chapters in great detail, that all of the end-use chapters and several other chapters had one key message which was very common, and that was that we have kind of reached, well, I wouldn't say that we reached the limit of pushing efficiency of individual gadgets, but we have become very good at that. And the real advances we have to expect now on moving towards systemic efficiency and holistic approaches. Most concretely, for example, the industry chapter says the large gains will not come from narrow process efficiency improvement, but from application of broader system optimization strategies. They also state that the only way to cut energy consumption in industry more than marginally is to use much less of the products of industry and to sharply increase the rate of product reuse, renovation, remanufacturing and recycling. which means that this is not only integration, system integration in one sector, but we really have to look at system integration across the whole economy. And this is such a challenging task, I believe. Even the scenario work, for them, even that was quite hard to capture. And if we think about it, there are really fairly few policies and policy framework that are really able to cut across so many parts of the economy. In the building sector, I will definitely show that by individual product efficiencies, we can't really go beyond. Even 20–30% improvement is quite an optimistic one, whereas if you go to looking at building as complete systems, it's fairly easy to achieve as high as 90% reductions. The urban chapter also, the transport chapter also had similar conclusions. In the urban chapter, it says, in urban areas, systemic characteristics of energy use are generally more important determinants for the efficiency of urban energy use than the characteristics of individual consumers or of technological artifacts. So basically, just like Bob also mentioned, systems, I believe that's the overarching key message from GEA. And there is much more to be done on that level. So with that, let's turn to the buildings sector more specifically. Buildings are key to sustainable systems and sustainable energy transformation because about almost 1/3 of global final energy demand currently comes or is consumed in buildings. 60% of the world's electricity is used in buildings. 1/3 of energy-related CO2 emissions, 2/3 of halocarbon emissions, and about 1/3 of black carbon emissions. So improving buildings and their equipment often offers one of the key entry points to addressing these challenges. The good news is that fairly recent advances in what we know about buildings and holistic solutions have been quite remarkable. And now there are lots of very high energy buildings that exist almost throughout the world, although unfortunately more prevalent definitely in the developed parts of the world. And combined with the very high efficiency of buildings, you also see that we start to move into on-site and community-scale renewable energy sources. So with the combination of the two, buildings could potentially become zero net energy or even net suppliers. And I will definitely discuss this point a bit more later. So these are just a couple of examples of buildings that are extremely low energy users. They come in all kinds of shapes and uses and urban and rural and commercial and residential and so on for all kinds of tastes. Unfortunately, as I said, they are still mostly in the developed part of the world, but we also have a couple of passive houses, even in retrofits, even in California here. That was very nice to see. But there are even the mass products. This is a building in Hungary, in Dunaújváros, one of the industrial areas. As you see, this building is identical to this one. It was retrofitted, and after retrofit, it has been saving 84% of total heating and cooling and hot water energy. This was done without any rocket science, fairly simple approaches, just applying the systemic solutions. And the great thing about it is that residents just love living there, and their quality of life has very significantly increased. And there is a lot of these buildings all throughout former Eastern Europe, hundreds of thousands, and former Soviet Union, Eastern Europe. So that was just a highlight about the elements of the solutions. But what's also important to emphasize is that beyond technologies, what we are usually much worse at understanding is the role of lifestyles, culture, behavior. And sometimes it's a touchy issue, but the GEA, the Global Energy Assessment, has not shied away from really making advances in this, and Jayashri will speak this afternoon more concretely. But I did want to show just one example how extremely important is culture and behavior, even in the building sector. If you look at per capita residential energy use, how it's broken down in the different countries, what you see is that in Japan, the heating and cooling energy use, this is climate corrected. so normalized for climate. So heating and cooling energy use on a per capita basis is significantly less, not only as compared to the US, but even as compared to Germany, where buildings are actually quite technologically energy efficient. So that really points to the tremendous importance of culture. We know that the Japanese, despite being one of the richest and one of the most affluent in the world, they are very prudent about heating energy consumption. They really use a service approach. If you have visited Japanese homes, they have the kotatsu system where they really heat only the feet so that you feel comfortable, but they don't heat the whole room. And so they're very sophisticated cultural solutions, and they use even in these times when they could afford clearly much more heating energy use. So these were the elements of the solutions, but let's see, or highlights from the elements of the solutions. You can look at for the details in the chapter. But let's see, if we put all of this together, how far can the building sector help us in the global energy transformation? So we have worked together with YASA on the scenarios, and we've done the building scenarios in harmony with the global scenarios. I have 6 minutes still here. We have found that about almost a half of global total final heating and cooling energy use reduction is possible by the middle of the century as compared to 2005. And this is attainable despite the enormous increase in building floor space that is expected, despite the enormous increase in service levels, and despite the artificial constraints that we provide energy access and sufficient thermal comfort to everyone. So this is the building scenarios. It's energy use, as you see, is going down. This is the efficiency scenario. And this is, at the same time, why floor area is increasing by 126% in the same period. So that's quite a reduction in energy use. And the investment costs are definitely substantial. We shouldn't shy away from that statement that we will need about over 14 trillion US dollars in undiscounted investments. At the same time, consumers, end users, are going to save almost $60 trillion also in undiscounted energy cost savings. It's also true that in places where we expect a significant service improvement, there is much less of a decrease, much less of savings, but at least you still will cut roughly even between investments and savings, such as in Africa and in India. So this was the nice news part. However, there is a very significant lock-in risk, which we quantify the first time. The blue is basically the scenario that I've just shown you, that it's possible to reduce just with the proliferation of today's best practices by half the energy use of 2005. But at the same time, we've also drawn a scenario in which we just modeled, what if we implement all the good and ambitious policies to the most ambitious levels that are presently different governments are planning. And the sad news is that even if we do everything what we said in 2010, then we will still increase global building energy use by about a third. So that represents about 80% of 2005 energy use lock-in risk. So we are locking in that much energy use, which we are not going to be able to come back at in the next few decades, because once you build a building or once you have a major retrofit, it's either extremely uneconomic to implement new energy efficiency measures for a few decades. Once you've changed your doors, you're not going to rip them out and put new ones in until they work and they're fine, or sometimes it's physically even impossible. So that's it's a very significant lock-in risk, which is really, we are determining now with present policies, because all of these have a long lag time. So we are locking ourselves in even with today's policies. So for this reason, we need very strong political commitment, but also because there are many barriers in this particular sector. So the only way to realize the efficiency pathway is through a very strong political commitment and diverse, ambitious and concerted policy packages. The good news part of this is that there are already quite some level of political commitment around the world having shown by different regions. And also we have a diverse portfolio of different policy instruments used throughout the world, helping to cut energy use already at negative costs. We looked at policy evaluation reports, and from all over the world, we looked several hundreds of them, and they have been shown to have been cutting energy use already from minus 13 cents per kilowatt hour to plus 4 cents, US cents per kilowatt hour all throughout the world, even in developing countries. So as a result, we even see that in selected developed countries, there is already a stagnation of building energy use. In fact, some countries started to see a decline in energy use despite the increasing service levels. So this is what I mentioned, that fortunately we even see, well, I could say political commitment. Sometimes it's more political rhetoric, but at least on the rhetorical level it's recognized that this is important to a very ambitious improvement in energy efficiency levels in buildings. These are just some of the commitments that were in place already in 2010. Since then a lot more happened, and here we are not talking about incremental improvements. These all demonstrate sometimes an 80 to 90% improvement in the energy use of new buildings as compared to 2005 building codes, for example. And like, for example, in Denmark, which was already extremely energy efficient, as compared to 2006, we see a mandated 75% decrease in specific energy consumption. So I don't think there are many other energy end uses or energy technologies where you can really see a 75 to 90% improvement in efficiency. So there is a lot of technical possibilities, and there is also the political commitment in some places is also there, and it is taking place. However, here comes the controversy. It was very interesting that my team, I had really an excellent team, I'm just too short in time to put all the names up. We all went into the GEA with a conviction and this vision that, for example, the World Business Council for Sustainable Development they had a vision that all buildings in 2050 should be everywhere in the world net zero energy, and they all said, it was the industry who said, this is all construction industry, said it was possible. Now, after the 2 years or 3 years of the work, we came away giving up this ambition, and in fact we concluded, and we agreed to conclude, the entire team, that in fact requiring buildings to be zero net energy is not likely to be the best solution, either cost-wise or sustainability-wise. In fact, they are not even always feasible. They are feasible only in certain locations and only certain building types and uses. For a hospital in Singapore, in a densely built environment, it's almost fully impossible to build a fully net zero energy. So if you want zero fossil energy buildings, we recommended an approach that first you bring your building energy use down to as low as possible, and then look at all available waste heat and waste energy sources. And after you utilize those, only then you start thinking about whether it makes more sense to produce the remaining energy on-site, or maybe it may be more environmentally efficient or cost-efficient to buy the remaining energy from sustainable sources from outside. So we are not okay. So basically, we did not conclude that. So we just want to warn the world that zero net energy buildings are very politically sexy and attractive, but they are not necessarily the best solution. Rather, go for very low energy buildings and combine the best possible energy sources to it, what's best locally. So, in concluding, first, I've shown that recent developments, mainly systemic know-how and systemic understanding about holistic solutions, and here I talk about both integrating industry to the users and so on, enable that the building sector can play a very significant role in building global energy use down. For example, I've shown that by the middle of the century, it is possible to almost halve building energy use as compared to 2005, despite an almost 130% increase in floor space, and while providing everyone sufficient access and full thermal comfort levels. However, I have shown that there is also a very significant lock-in risk, and personally I find this the most alarming because politicians don't understand. The EU policy got very alarmed when they read these reports, because we are running into a situation where we are locking in at least 80% of today's building energy use by the middle of the century. So due to this and the very strong barriers that prevail in this sector, we need very strong political commitment, which is more than just rhetoric, and transformative policy packages which go beyond the incremental change and which are not going to be easy. And only those can put us on the low scenario that, or the efficiency scenario that Naki will show. The good news part was that I have shown that both technology-wise and policy-wise, there are many good examples and best practices worldwide, and there are already many policies saving energy to the end users at negative costs or at very low costs. But this is very far from enough. We need significant upscaling, and in the existing policies, which are supposed to be ambitious, we need much more ambitious performance levels closer to the state of the art in order to prevent the lock-in. And finally, I made a point that before we jump into praising net zero energy policies, we should think carefully whether they are really the best solution in the particular situation. Thank you very much for your attention.